In this video, we're going to go over how to do a simple lathe part as easily and quickly as possible. Emphasis on the quick and easy part. We're not going to get into all kinds of details and possibilities of different paths to take to do the job. First of all, let's look at the part we're going to do. It's a very simple little pin kind of part here. It's just a chamfer, a couple of chamfers, 1-2 diameters. There's nothing really to it at all. In fact, I know a lot of people would say I could probably do that by hand on the lathe just as fast. I think if you follow what we do right here, once you become a little proficient at it, I think you'll find you can actually do it a lot faster here. I've done both in my life, and I do believe that this is faster, but it's not for everybody. Anyhow, let's go back to Power Station, and we're going to jump right into Geometry, EZGeometry, Lathe Geometry. All right. So now we just start with this command. We just start picking items from the print. We're starting. It's already assumed 0, 0, so it's already starting right here. The first thing we want to do is say this diameter that we're going to get up to here. So we say diameter and the size, which was 0.43. One thing about EZGeometry, always move off of the box that you're editing. When you move to the next box, you want to make sure that this box stops editing. Next item will be the chamfer that we're putting on, which is 20 thousandths, whoops, 0.02. Okay. Next item will be, that's the chamfer. Next item will be this shoulder. We're coming back to this area here, so that's minus 1.825, a shoulder of minus 1.825. Didn't have my numlock key on. A shoulder of minus 1.825. Okay. Next thing we come up to is this diameter. That's where this angle is going to start. So this diameter here is a ½ inch, 0.5. So I'm going to say come to a diameter of 0.5. All right. So the next thing will be this little taper angle here. So it's not a 45-degree chamfer, so we can't use the chamfer command. We'll use the taper command to make this. It's 30 degrees off of the vertical, so it's really at 120 degrees. So we'll say a taper of 120 degrees. Okay. And the next thing we're hitting will be a diameter of 0.5774. Diameter. 0.5774, and the last thing will be this shoulder, this final overall length, minus 1.975. It's a shoulder. It is at minus 1.975. Okay, again, move off of that field where you were just entering, and you can say show. It shows you what it looks like so far. Kind of small. You might want to hit extents here to get it up nice and big. So there, in just a few quick commands, you develop the overall scheme of the part here. So that looks good. That looks good. We're going to take it. We're going to say, okay, if you forgot something, if you forgot another little feature, another diameter, or a little fillet somewhere or something, you can simply go where you want to put it, press add, and then add it in the list, and say show again. Nothing is committed until you finally say OK. When you say show, it's just giving you a preview of it. So when you say OK, now the geometry is there. And that geometry is the same as if you created it the longer way by defining each individual line or arc or whatever it is you're going to define. Now, here we're going to jump to a very common requirement on in turning, or not so much requirement, a nice touch. I know I always used to use it, and I know a lot of people who like the nice touch. I want all of these corners, these little outside corners, to have a little fillet on them, a little radius on them. I'm going to go with 5 thousandths. One of the commands that is a darn handy command when you can use it. It's not always applicable to everything. Sorry, it's in the trimming menu here. But in this case, it's kind of perfect. It's called the fillet chain command. Is this the one here? Yeah, fillet chain. And here's what you do. So fillet size for right turns. At this point, this isn't really going to make any right turns where you got lines bumping into lines. They're all, the only right turn is right here, and you don't want anything in there that's going to be the tool radius, unless it was something bigger than the tool radius, I guess. But let's say, so for right turns, we just leave it 0. But for left turns, as these two are, 1, 2, they're turning left as you're cutting along. Let's say we want those to be 5 thousandths. You can say OK. Say start the boundary. Escape, because we're going to select the entire boundary. And boom, it threw radiuses in all of those in 4 locations there. You can see now on the tips right here, we've got our nice little 5 thousandth radius. Okay. Let's go. Let's go right to machining. We're not going to fool around with dressing this up or drafting or anything else. Let's get to the G codes as quick as we can. So we'll need an operation. You can either sit and define the operation step by step. You can use the tool and material library. One of the another nice feature of the system is it hangs on to every operation you ever did. So if you are commonly using just about the same tools for roughing and finishing and stuff, I'm sure if I pick rough turn, it's going to be something close to what I want. And if I take a look and I say it's turning, well, that's got some stock allowance on it. Let's get rid of that. I'm not really doing a rough turn. I'm going to go right into just making a finish cut on this thing. All right, what's the tool shape? Say it looks like an 80-degree diamond. Okay. Yes. So you select the operation to be current. You say yes. And it's simply a chain cut. You say I want a chain cut. I want to start right here. I want to chain the whole thing. So you press escape. Entity's chained okay. Yep. You got to give it the side to offset to. So I want the tool on this side of that starting line. See, not on it, but to the side of it. Okay. And now you just fill in your cutting preferences. In this case, we're only trying to just make a finish pass around this. All of the default options should probably be fine. We may want to change the cutting feed rate a little bit for what we're doing. We're in OD, that's good. The only thing I like to do is retract Z when done, so I'm sure that it will run back out to the face before it heads anywhere. I think it's a little better way to go. Again, purely your option. Okay, and boom, it started down here, walked its way around here, and then head home over here. Okay. We've got that. Let's go right to generating the code. We come down here to generate NC code. We select the machine name. In this case, I'm going to just go with demo lathe because it is a pretty standard type lathe post and covers an awful lot of machines. I'm going to name the program my favorite name, Steve. And you just say go. All right. It generated the code. You can say view code and have a quick look at it up here. Okay. Now I only did this much for a very simple reason. I have found over the years that the overwhelming majority of lathe programmers say to me the same thing. That's good, that's great, that's all I need. Just give me that and I'll throw it in my machine, I'll throw a G70, G71 on it, whatever I need to rough and finish it. Don't worry about it, that's what I need. I just need that right there. All right. If that's the case, here you are. There it is for you. All right. If you want to add, if you want the system to add roughing and finishing, or call in the G71, I think there's the roughing one. That can all be done. I'll explain that very quickly here, but basically you went right to this. This is now stored on your disk. If you go into either of the PowerStation editors, either the PowerStation Windows Desktop or QuickLink, you can find this file. The default place would be /PS for the PowerStation folder, /tapes. Whatever you name this file, which I just called it Steve, it'll be over there. If you just wanted to print it out, you could print it right here. You don't have to bother to load it there. If you're sending it out to a machine, DNCing it in, you would need to use Windows Desktop or QuickLink to do that.